Mga migs, welcome to Winnie Luna Nahial Eduk channel on mathematics and other related topics. In this video, our discussion is about nominal, effective, and equivalent rates. This is another lesson or topic in our subject, or this is a lesson of the subject mathematics of investment. Let R sub 1 and R sub 2 be distinct interest rates. If these two rates accumulate the same amount of money over the same period of time, then these rates are considered equivalent. Again, R sub 1 and R sub 2 are distinct interest rates. If ever they gain the same amount of money after an investment period, these two interest rates are considered equivalent. For every nominal rate that is rate converted semi-annually, quarterly, or monthly, there is a corresponding effective rate that is rate converted annually and vice versa. Also, for every nominal rate R sub 1, there is a corresponding equivalent rate R sub 2. Now, let W be the effective rate and J be the given nominal rate. Take note, our W in this lesson is that this W is the effective rate and this J is the nominal rate. And we have this formula, the effective rate. So in this formula, it is the effective rate is the unknown. So W equals this group 1 plus J over M. Then this group is raised to M minus 1. In order to solve for the equivalent nominal rate given an effective rate, we use this formula. So J is our nominal rate. This is equal to M times the group 1 plus W raised to 1 over M, then minus 1. The formula of getting the nominal rate, which is represented by this lowercase letter J, is just a derivation from the given formula of knowing the effective rate. This one, effective rate. So you can you can use this formula, you can solve for J in order to get this formula. Also, to find an equivalent nominal rate J sub 2 converted M sub 2 given nominal rate J sub 1 converted M sub 1. We have this formula. J sub 2 equals M sub 2 times the group. We have the quantity 1 plus J sub 1 over M sub 1 raised to M sub 1 over M sub 2. Then the quantity is subtracted by 1. Now, what is nominal rate? Let us recall so that we could master the meaning of nominal rate. The nominal interest rate is the stated interest rate of a bond or loan, which signifies the actual monetary price borrowers pay lenders to use their money. If the nominal rate on a loan is 5%, borrowers can expect to pay 5 pesos of interest for every 100 pesos loaned to them. It is often referred to as the coupon rate because it was traditionally stamped on the coupons redeemed by bondholders. Nominal interest rates refer to the interest rates that are unadjusted for inflation. In other words, it is the stated or quoted interest rate on a loan or investment without taking into account the impact of inflation or deflation over time. Nominal interest rates are typically expressed on an annual basis, such as 5%, 7%, or 10%, and they represent the percentage of the loan or investment principal that must be paid as interest during a specific period. So one thing that is sure in this nominal rate is the idea that the agreed nominal interest rate will be the same interest rate to be paid by the borrower if ever there will be inflation or deflation. So that is the agreed interest rate. Remember, real interest rates can be negative even if the nominal rate is positive. Inflation can erode purchasing power so far that money loses its value when held on to. That is according to the International Monetary Fund in 2020. Now let's have also effective rate. Let's understand this one. Investors and borrowers should also be aware of the effective interest rate, which takes the concept of compounding into account. For example, if a bond pays 6% annually and compounds semi-annually, an investor who places 1,000 pesos in this bond will receive 30 pesos of interest payments after the first 6 months. That is 1,000 times 0.03. Why is this 0.03? Because our nominal rate is 6% and compounded semi-annually. So we have to divide 6% by 2 or 0.06 by 2. You get 0.03. Okay? This is the reason that only 3% is used for every compounding period because our nominal rate here is 6% annually but compounded semi-annually. And so for the first 6 months, that's gonna be 30 pesos for every 1,000. Now, for the second compounding period or for the next 6 months, the borrower has to pay 30 pesos and 90 cents of interest after the next 6 months. That is 1,030 times 0.03. In total, this investor receives 60 pesos and 90 cents for the first year. In this scenario, while the nominal rate is 6%, the effective rate is 6.09%. Mathematically speaking, the difference between the nominal and effective rates increases with the number of compounding periods within a specific time period. So it is quite clear that as the number of compounding periods increases, the amount also will increase. Illustration. Calculate the equivalent effective rate for a nominal rate at 10% compounded every 2 months. So our nominal rate here is 10% or 0.10. Then the number of conversion periods is 6 because the amount or the investment is compounded every 2 months. So in a year, every 2 months, so there are 6 compounding periods. And then we have to use the formula of getting the effective rate. So we have W equals this group 1 plus 0.10 divided by 6. Then this group is raised to 6, then subtracted by 1. Now, this 0.10 divided by 6, that is equal to 0.016666, repeating, then plus 1, that is 1.016667, then raise it to 6, then subtract by 1, then you have 1.1043 minus 1, so you have 10.43. So this is the effective rate of the nominal rate at 10% compounded every 2 months. So we can see that the effective rate is higher than the nominal rate by 0.43. Another illustration, determine the nominal rate equivalent to 16% effective rate compounded semi-annually. So it is now the nominal rate that is the unknown, and we are given the effective rate of 16%. Then compounding periods, compounded semi-annually. So there are 2 compounding periods in a year. Then we have to use the formula for the nominal rate, which is represented by the lowercase letter j. Then we have to substitute m by 2. Then do the calculation. You will have this 1, 2 times the group, 1 plus 0.16. Then the sum is raised to 1/2. Then the result is subtracted by 2. So you have 2 times the group, 1.16 raised to 1/2 minus 1. So you will get j equals 0.1541, or that is 15.41%. So this is the nominal rate equivalent to the effective rate, which is 16%. Again, in this illustration, we see that the effective rate is higher than the nominal rate. Then, what nominal rate compounded quarterly is equivalent to 6.5 compounded semi-annually? So we have here our J1 is 0.065, or that is 6.5%. Our M sub 1 is 2 compounded semi-annually. Then we have compounded quarterly. Then our goal is to find J sub 2. So we simply use the given formula. This one, use this given formula. And then substitute right here. Then do the calculation. So this 2/4 becomes 1/2. Then this 0.065, that is divided by 2 because we have two compounding periods here. Then our M sub 2 is 4 because we are looking for the nominal rate compounded quarterly. Then minus 1. Then do the calculation. You have J sub 2 is equal to 0.0645 equals 6.45%. Okay, so that is the nominal rate equivalent to 6.5, that is compounded semi-annually. I hope you got something from this lesson. Thank you very much.